Okay, so we are going to go over part 1 review that you got in class today, okay? So I'm going to go through each problem and we're going to talk about the things that I want you to remember for the semester exam, okay? So let's start on number 1, okay? -6 minus -4. Okay, so these are integers, so we're going to need to go back to our integer rules. Okay, so in your journal you have integer rules, and remember we first need to look at the operation. Okay, so the operation that's happening here is subtraction. Okay, so when we subtract integers, okay, we have to keep, change, remember? So we're going to keep the -6, change subtraction to addition, and now change the addition, or excuse me, change the -4 to a +4. Okay, so now we are adding with different signs. Okay, adding with different signs means subtract and keep the sign of the larger number. So the 6 is larger, so we know our answer is going to be negative. Okay, so 6 minus 4 is 2. All right, so our answer there is -2. Okay, so I need you to make sure that you are memorizing those integer rules for the exam. There's going to be computation problems just like this with positives, negatives, decimals, fractions. Okay, so remember that. All right, 4 plus -8. Now that goes back again to our integer rules. Okay, we are adding with different signs. This 4 is positive and this 8 is negative. So when we are adding with different signs, we subtract and keep the sign of the larger number. Okay, the larger number is 8. Okay, so we know our answer is going to be negative, and 8 minus 4 is 4. Okay, so if we go back to those integer rules, we can solve that problem pretty quickly. Okay, now 14 minus 24. Okay, again, go back to your integer rules, keep, change. Okay, so keep the 14 positive. This subtraction sign changed to a addition sign, and the positive 24 changes to a negative, -24. Okay, so now you have 14 plus -24. All right, now again, we are adding with different signs. Adding with different signs means subtract the numbers and keep the sign of the larger number. Okay, the larger number is 24 and it's negative, so our answer will be negative. And 24 minus 14 is 10. Okay, so -10 is our answer. All right, now number 4, we have -2 times 14. Okay, so now we're multiplying. Okay, let's think back to our integer rules one more time. When we have a negative and a positive, those are different signs, and you're multiplying, your answer is negative. Okay, now 14 times 2 is 28. Okay, so our answer is -28. All right, 14 divided by -2. All right, so let's write it like this, 14 divided by -2. All right, now when, again, if you are multiplying or dividing with different signs, your answer will be negative. So 14 divided by, we already know our answer is going to be negative, so we can kind of disregard that -2. Okay, we've already dealt with that. So remember, 14 divided by 2, we just divide like normal. That gives us 7. So our answer is -7. Okay? All right, now when you come and you are dividing with decimals, okay, this is 8 divided by 0.02. Now remember, when you're dividing with decimals, this number out here needs to be a whole number. Okay, so we get a whole number by moving your decimal 2 places to the right. Now if you move your decimal out here, you have to move your decimal in here on the inside the same number of times. Okay, so I'm going to extend my line here and put my decimal right up at the top so I don't forget where it goes. So now this is, I fill in these gaps with the zeros. Now this is 800 divided by 2. Okay, so you can rewrite it if you want. Okay, we can say 800 divided by 2, if that's easier for you to read like that. Or we can just keep it like this, okay? So 2 goes into 8 4 times. Okay, 4 times 2 is 8. Subtract, bring down your 0. 2 goes into 0 0 times. 0 times 2 is 0. Subtract, bring down this last 0. 2 goes into 0 again 0 times. Okay, so I get 400. Okay, all right, 0.04 times 2.5. Okay, so I'm multiplying two numbers with decimals. I do not have to line up my decimals when I am multiplying. Okay, only line up your decimals when you are adding or subtracting. Okay, when you're multiplying, you do not have to line up the decimals. So let's go ahead and multiply like normal. 5 times 4 is 20. 4 times 2 is 8, plus 2 is 10. Okay, placeholder down here. 0 times 5 is 0. 0 times 2 is 0. Okay, add up my numbers. Now, I have 1, 2, 3 numbers to the right of the decimal up here in my multiplication. So I need 1, 2, 3 numbers to the right of my decimal in my answer. Now, this line right here is for this problem number 8. I just ran out of room. So really this says 0.100 or 0.1. All right? And that's the same thing as saying 0.1. Okay? All right, now we have 53 minus 7.41. Okay, so this is the scenario where I was talking about if you have decimals and you're subtracting or adding, you have to line up your decimals. So we are going to put the bigger number on top. And if we are subtracting 7.41, we're going to need to add 2 zeros to this top number so that when I line up the decimals, I have 2 zeros up on the top here, okay? So now subtract, just like normal, okay? 0 minus 1, you can't do that, okay? Borrow, can't borrow from that 0 yet. So 3 becomes 2, this becomes 10, okay? Now we can borrow from the 10 to make it 9, and that becomes a 10. So 10 minus 1 is 9. 9 minus 4 is 5. Okay, 2 minus 7, we can't do that, so go ahead and borrow, make that a 4, make that a 12. Okay, 12 minus 7 is 5. 4 minus 0 is 4. Okay, now that we've lined up my decimals, go ahead and just bring that decimal point all the way down. Okay, so I get 45.59. All right. Now, 10 minus 2.45. Same thing again. 10 minus 2.45. Line up those decimals. Okay, and we're going to have to borrow again, just like before. That becomes a 0. That becomes a 10. Borrow from the 10. That becomes 9. That becomes 10. Borrow from here to make that 9 and this 10. 10 minus 5 is 5. 9 minus 4 is 5. 9 minus 2 is 7, okay, and 0 minus 0, 0. And bring down your decimal. So 7.55. All right, back up to the top here. 21.3 plus 0.07, okay? Now I'm adding with decimals, so I have to still line up the decimals, okay? And I'm adding 0.07, so I need to add a decimal, add a 0 up there. Okay, now I'm adding. So 7 plus 0 is 7. 3 plus 0, 3. 1 and 2. Okay, and just bring down your decimal. So 21.37. All right, now 4.7 times 3.9. That's like this problem over here. We did not have to line up our decimals. Okay, just multiply like normal. So 4.7, okay, times 3.9. All right, so 9 times 7 is 63. 9 times 4 is 36, plus 6 is 42. Okay, add a 0. 7 times 3 is 21. 4 times 3 is 12, plus 2 is 14. Add them together. 3 plus 0 is 3, 2 plus 1 is 3, 4 plus 4 is 8, and 1. Now I have two numbers to the right of my decimal. So two numbers to the right of my decimal. So 18.33. All right. Now we are getting into fractions. Okay, so I have a mixed number times a whole number. Okay, before I can multiply these fractions, I need to change this mixed number to an improper fraction. We use popcorn. Okay, so 4 times 2 plus 1. Now I could change this mixed number to a decimal. If this is 4.5, I could say 4.5 times 2. But I want to get practice with fractions, okay? So let's change this to an improper fraction. 4 times 2 is 8, plus 1 is 9. 9 over 2 times, now that's a whole number too, so I have to put that over 1, okay? So 9 times 2 is 18, okay? And 2 times 1 is 2. Now, 18 over 2, or 18 divided by 2, if I simplify that, that just simplifies to 9. Okay? All right, now two more fractions that I am multiplying together. When I multiply fractions, I multiply straight across. I forgot to say that up here. Multiply straight across. So these are already lined up fine. Okay, let's just go ahead and multiply. 12 times 1 is 12. Now, 15 times 3, we can multiply that over here. 5 times 3 is 15. 3 times 1 is 3, plus 1 is 4. Okay, so 12 over 45. All right, now we cannot simplify. Well, yeah, we can simplify by 3. Let's do 3. Okay, 12 divided by 3 is 4, and 45 divided by 3 is 15. There we go. Okay, so 4 over 15 is our simplified answer. Okay, if you were to give me this on a test, I probably would accept it. Okay, but please make sure you think about, can I simplify the fraction? If you can, go ahead and do that. If not, then just leave it how it is. Okay. All right, so now we are dividing fractions. Remember, keep, change, flip. Okay, so keep the first fraction, change the division to multiplication, and 1/3 changes to 3 over 1. We keep, change, flip this second fraction. Then it becomes multiplication, and you multiply straight across. 4 times 3 is 12, 5 times 1 is 5. Now, this is an improper fraction, okay? We need to divide to change that back to a mixed number like we had up here, okay? So top dog in the house, 5 goes into 12 2 whole times. 5 times 2 is 10. Subtract. Now, we don't want to go through and make a decimal, okay? We want a mixed number. We want a mixed number that's a whole number and the leftover fraction, okay? So this becomes 2 wholes and 2 over 5. 2 wholes and 2 over 5. 2 and 2/5. Very good. All right, here's 2 more fractions we are multiplying, but these are 2 mixed numbers. So before we can multiply them, we need to change both of these to improper fractions. Using that popcorn again. All right, so 3 times 1 is 3, plus 1 is 4. Keep your denominator, 4/3. Times, now 2 times 2 is 4, plus 1 is 5. So 5 over 2. Now, remember, I don't need common denominators because I am multiplying straight across. So 4 times 5 is 20. 3 times 2 is 6. Okay? So now this is, again, an improper fraction. So we need to divide, but we can go ahead and simplify. Let's simplify by 2 to give us 10 over 3. Then we can divide. 10 divided by 3. Okay, 3 goes into 10 3 whole times, and that gives us 9. All right, and remember, we do not want to go on and add a decimal and a 0, because we want 3 wholes and the leftover fraction. So 3 wholes and 1/3. This is your numerator in your fraction, and this is your denominator. So 3 and 1/3. Okay? All right, dividing fractions. Now this can be a fraction. Remember, we can put that over 1. So change flip again. Keep the 5 over 1. Change division to multiplication. And 3 over 4 becomes 4 over 3. All right, now 5 times 4 is 20, and 3 times 1 is 3. Okay, so now we can't simplify that anymore, so let's go ahead and divide to make it a mixed number like we did up here. So top dog in the house, 20 divided by 3. 3 goes into 20 8 times. No, 7. No, 6. Sorry. 6 times 3 is 18. There we go. It's late. Okay, subtract, we get 2. All right, so 6 wholes and 2/3. Okay, remember, this is your numerator, this is your denominator. So 6 and 2/3. Very good. All right, and last one on this page, dividing fractions again. All right, so we need to change this mixed number to an improper fraction using popcorn. And this 7 becomes 7 over 1. Okay, so we need 2 steps before we can actually divide the fractions. All right, so change this. 2 times 3 is 6, plus 1 is 7. 7/3. Okay, remember, we're changing this to multiplication, and this is 7 over 1, so what do we flip it to? 1 over 7. All right, now multiply straight across. 7 times 1 is 7. 3 times 7 is 21. Now we know we can simplify both of these by 7 to get 1 over 3, or 1/3. All right? Okay, let's go on to the second page. Okay, so again, now we are subtracting fractions, okay? So 5 minus 2 3/4. Okay, change this to an improper fraction. Change this to a fraction with 1 in the denominator. So popcorn one more time. So 5 over 1 minus, now 2 times 4 is 8, plus 3 is 11. So 11/4. Okay, now these do not have common denominators, these two fractions. First thing we need to do before we can subtract these fractions, we need to find common denominators. Okay, now the way we can find common denominators, you can use the least common multiple, list all the multiples of each denominator and find the one that occurs the least, or you can multiply both denominators. 4 times 1, which is 4, and that can be your denominator. Okay, so this is already in a fraction with 4 in the denominator, so we need to change this fraction to a fraction with 4 in the denominator. So I'm going to kind of do this off to the side. We're changing 5 over 1 into a fraction with 4 in the denominator. Now, I wrote equals because these are actually going to be 2 equal fractions, okay? So 1 times 4 is 4. So I need to do the same thing up here. 5 times 4 is 20. Okay, so that becomes 20 over 4. Okay, so before I can even subtract, I have to use this fraction and subtract 11 over 4. So 20 over 4 minus 11 over 4. All right, now I can go ahead and subtract because I have common denominators. So the larger number is already in the front, so 20 minus 11, that gives us 9. So remember, subtract the numerators, keep the denominator, 9 over 4. Now last step before that's our final answer, we have to change that to an mixed number by dividing. So 9 divided by 4. 4 can go into 9 2 times. That gives you 8. Okay, so now 2 wholes and 1/4 is our answer. 2 1/4. Okay? All right, so another one just like that. Change these to improper fractions using popcorn. 4 times 2 is 8, plus 1 is 9. 9 over 2 minus, okay, so here's another 4 times 2 is 8, plus 3 is 11. All right, these were the same fractions. So now, okay, still I cannot subtract because I don't have common denominators yet. So here, I don't need to multiply these two together to see what my common denominator would be. I can already tell that this 2 right here, I can tell that I can change that easily to match this 4. So that way I only have to change one fraction instead of changing both fractions, okay, to make common denominators. So over here off to the side again, 9 over 2, I'm going to change that to a fraction with 4 in the denominator. So 2 times 2 gets us 4. So 9 times 2 is 18. Okay, so before I can do anything, that 9 over 2 becomes 18 over 4. Now I can subtract 11 over 4. Okay, so when I subtract, okay, 18 minus 11 gives you 7, or I can write enough room. And 4 minus 4, well, we don't subtract the denominators. We subtract the numerators. Keep that denominator. So 7 over 4. Now, here, let me separate these problems. Okay, now this 7 over 4, again, is an improper fraction. So we need to change that to a mixed number by dividing. Okay, 4 goes into 7 only one time. Okay, 4 times 1 is 4. So 7 minus 4 is 3. So this mixed number becomes 1 and 3/4. All right. Okay. All right, now change these again to improper fractions. And now we're going to be adding, okay? So 5 times 4 is 20. 20 plus 3 is 23. It's 23 over 4. All right, and 9 times 7 is 63, plus 4 is 67 over 7. All right. Now, again, I need common denominators. So I know that the 4 cannot change to a 7, and the 7 can't really change to a 4. So this is a circumstance where I can say, okay, 7 times 4 is 28. So I can change both of these fractions into 2 new fractions with 28 in the denominator. So I'm going to do that off to the side over here. Okay, so I want 28 in the denominator. Okay, so I know that gives 4 times 7 is 28. So we need to do 23 times 7. That's going to be a big number. Okay, so let's do that down here. 23 times 7. Okay, 7 times 3 is 21. So 7 times 2 is 14, plus 2 is 16. So 161. All right, we've changed our first fraction with a fraction with 28 in the denominator. So let's do the same thing over here. So we want 28 in the denominator to match, so I can add them together. 7 times 4 is 28. Okay, 67 times 4. 67 times 4. Okay, so again, 7 times 4 is 28. Okay, 6 times 4 is 24, plus 2, 26. So 268. Wow, those are big fractions. Okay, but it's all right. We're adding them together. Let's rewrite these two fractions where we're adding them together, where it's easier to see. 161 over 28 plus 268 over 28. All right, now we have common denominators, so now we can add the numerators, keep the denominator. So down here we're going to do 268 plus 161. 8 plus 1 is 9. 6 plus 6 is 12. 2 plus 1 is 3, plus 1 is 4. So 429 divided by 28. All right, now that's what we get once we've added those two together. Okay, we need to divide to make a mixed number. Okay, wherever we have enough room. 429 divided by 28. Okay, so 28 into 42. Well, let's see, that can only go in once. Okay, and that gives you 28. Now we need to subtract. 2 minus 8, we can't do that, so borrow from the 4, make it a 3. So this becomes 12. 12 minus 8 is 4. 3 minus 2 is 1. Bring down your 9. All right, so let's try 28 times, let's try 6. 6 times 8 is 48. 6 times 2 is 12, plus 4 is 16. So that's a little too much. So let's try 28 times 5. 8 times 5 is 40. 5 times 2 is 10, plus 4 is 14. All right, so 28 times 5 gives you 140. Okay, and you have 9 left over. Okay, so this becomes 15 and 9 over 28. Okay, all right, so that is our answer. We can't really simplify any further than that. 9 and 28 can't be divided by the same number. Okay, so now we move on to equations and a couple inequalities. Okay, x minus 4 equals negative 7. All right, now we are trying to solve for x. Okay, remember x and 4 are being subtracted. So we need to do the inverse operation. We are using subtraction right here. So the inverse operation, to get this constant to go away, we need to add 4 to both sides. Okay, remember, because that gives us 0 for our constant. Okay, so we are adding 4. Bring down your x. Okay, so negative 7 plus 4. Okay, let's write it like this, negative 7 plus 4. All right, so we are adding integers with different signs, so we need to subtract and keep the sign of the larger number. Okay, the larger number is 7, so keep that negative sign. 7 minus 4 is 3. So our answer is x equals negative 3. All right, now we have some fractions over here. Don't get scared. Okay, y plus 1 and 1/3 equals 5 1/2. Okay, so we need to solve for y, but y is getting added to 1 and 1/3. So we need to do the inverse operation again. Subtract 1 and 1/3 from both sides. All right, remember that makes your constant become 0. So y equals 5 1/2 minus 1 and 1/3. Okay, so now this problem is just like, the subtracting fractions up here. Okay, so 5 1/2 minus 1 and 1/3. We need to change those to improper fractions using popcorn again. So 5 times 2 is 10, plus 1 is 11. 11 over 2 minus, so here's 1 and 1/3. 3 times 1 is 3, plus 1 is 4. Okay, so again we are subtracting, but these fractions do not have the same denominator. Okay, so we need to change both of these fractions into a fraction with 6 in the denominator on both sides to get in 2 new fractions. 3 times 2 is 6, so 4 times 2 is 8. 2 times 3 is 6. So 11 times 3 is 33. Okay. All right. So wherever I have more room, I'm going to rewrite these. Right. I'm going to make a column right here. So this is 33 over 6 minus 8 over 6. Okay. So 33 minus 8, okay, borrow. 13 minus 8 is 5. 2 minus 0 is 2. So this becomes 25 over 6. All right, we need to divide to change that back to a mixed number. 25 divided by 6. Okay, 6 times 4 is 24. Subtract. Okay, remember we want a mixed number, not a decimal. So 4 wholes, remember we're trying to find y, where I have more room. Y equals 4 and 1 over 6. That is our answer for that one. Okay? All right, number 23. X plus 0.06 equals 2.45. Okay? We are solving for x. So x and 6 are being, x and 0.06 are being added. So we need to do the inverse operation to get rid of our constant. And we can actually line it up right underneath the decimal so we don't have to rewrite it. That becomes 0. Okay, 5 minus 6, can't do that, got to borrow. Okay, 15 minus 6 is 9. 3 minus 0 is 3. 2 minus 0 is 2. Bring down your decimal. All right, so x equals 2.39. That's our answer. All right, y minus -4 equals -18. So here again, just like on the front, these are integers, so we can use our integer rules, okay? Y minus -4. Okay, remember that becomes, we keep change. So y plus 4 equals -18. Okay, so we are adding right here, so we need to do the inverse operation, which is subtraction. So that becomes 0. Y equals -18 minus 4. Okay. Let's write it out like this. -18 minus 4. Okay, these are subtraction of integers, so keep, change. So -18 plus -4. Now we are adding with same sign, so add and keep the sign. So 18 plus 4 is 22, and keep the negative sign, so -22. All right, that is our answer. Okay. -2y plus 10 is less than or equal to -8. All right, we're solving for this y. So this is our constant and this is our coefficient. We need to move the constant first using inverse operations. So -10 minus 10. Okay, that becomes 0. So -2y is less than or equal to, okay, this is -8 minus 10. Okay, keep, change. Now we're adding with same sign. So add and keep the sign. So -18. Okay. Now we are still solving for y. Y is being multiplied by -2. So I need to do the opposite of multiplication. Okay, the opposite is division. So divide by -2. Now, remember that becomes 1, but we divided by a negative number. Okay, so when we divide by a negative number, you flip your symbol. So this becomes y is greater than or equal to -18 divided by -2. That is a positive 9. Okay, so that is our answer. All right, last one. Make sure we have enough room here. -3x minus 9 is less than or equal to 3. All right, so the inverse operation to move our constant would be plus 9. That becomes 0. So -3x is less than or equal to 3 plus 9 is 12. All right, now we are solving for x, but x is being multiplied by -3. So the opposite of multiplication is division. So divide by -3. That becomes 1. So over here, I'm going to write my answer so I have more room. X, now we divided by a negative number, so flip your symbol. X is greater than or equal to, now this is a positive 12 divided by -3, so that is -4. Okay? All right, and that is it. So please make sure you know how to do all of these things, okay? These kind of problems will be on your semester exam. Okay, so if you don't know how to do some of these, look in your journal, look it up online, come ask me next week or next time you see me, okay? All right, thank you.